Hey guys, so this is the practice over 3.1, which we were going to use our other foldable, the one that's folded into thirds, to help us complete these problems. So since we practiced domain and range a lot, I want you to pause this video and go ahead and solve problems 1 through 4, and then unpause it, and when you're ready to unpause it, I will have all the answers put down so you can then check your solutions. So go ahead and pause your video and work out questions 1 through 4 now. Okay, so example 1 and 2 are just scatter plots. So remember, domain is list the x's off in these little brackets. Braces. And then range is list the y's off. So I think the first one's pretty easy to figure out. I made my table to help me. On the second one, if you miss this point at 0, 0 right here, lots of people do every year. I think it's kind of hard to see. So if you did not catch that there is a point at 0, 0, that's okay. Just go ahead and fix it now. So pause if you need to double check your answers, but I'm going to go ahead and show you 3 and 4. All right, so here are my answers for 3 and 4. Go ahead and pause the video if you need to so you can look closely and make sure that you got all the numbers and the symbols correct. Okay, so looking inside this foldable. So the first example says determine whether the set of points or the graph represent a function. All right, so if you look at this, remember what we did yesterday is we look at the x values. So right here, here are x values, and these two give me a problem because this is 5, 0, and this is 5, 10. So that means when I plug 5 into the function, I get 2 different outputs. So it is not a function. So is it a function? No. And so I'm going to say the input of 5 gets 2 different outputs. So each x value can only have one unique y value assigned to it. Okay, let's look at the next one. So look at the x values first. That's where we're going to find the problem. So you see how the x values are all different? So we're going to be good to go. So we're going to say, yes, it's a function. Because each x value is different, that means each input has exactly one output. Now remember, videos are great because you can pause if you need to catch up or process something, so pause as needed throughout this video. Okay, let's look at these graphs. Are they a function? So when it's graphs, our foldable says to use the vertical line test. So you look at graph on number 3. Is there anywhere that the vertical line goes through the graph more than once? So there is not. Picture a vertical line going through. It only goes through one time, only one time. Everywhere I go, the vertical line is just one time. So that's okay. So we're going to say it passes the vertical line test. And remember, we can abbreviate vertical line test as VLT. Okay, now on number 4, if you see, like right here, if I draw a vertical line in, it goes through the function twice. And so this is why it's like not okay. And so it's not a function, and the vertical line goes through the graph more than one time. All right, and so that's a problem. Okay, so that is a review from yesterday. Let's look at a new question. This says, make an input-output table for the function y equals negative 2x plus 3 using these inputs. So what we're going to do is we're going to have inputs, that's x, and output, that's y. So your x's, they told you, they said your inputs are negative 2, 0, 2, and 4. Okay, so how you're going to get your outputs is you're going to use this function. So what we're going to do is we're going to plug in each number to x. So like on this first one, we're going to plug in negative 2 where the x is. So if you guys see right here, that's where the x is. Now you can use a calculator or mental math, and you're going to end up with 7. So on this next one, we're going to plug in 0 where x is. So negative 2 times 0 and then plus 3. And we're going to get 3. And then we're going to do it again with an input of 2. So plug the 2 in, and once again, calculator or in your head, you plug the 2 in where x goes. So you have negative 2 times 2 plus 3. That's negative 4 plus 3, which is negative 1. And then last but not least, let's plug in the input of 4. And so that gets me -5. and feel free to use a calculator or work some more work out. But when I want an input-output table, that's what I'm going to do for that problem. I'm going to put up my inputs on X, and it's whatever they tell me, and then I plug each one in to the function, and that's how I get out my output, which is Y. Okay, and then our last thing today, this is a little bit of a review. We barely got to start this in class yesterday. So independent and dependent variables, okay? So it says the function y equals negative 3x plus 12. Okay, so this is our equation. Represents the amount y. So y is the amount in fluid ounces of juice remaining. And x is the number of gulps. So think about this way, okay? And you don't have to write this down. I'm just giving you something to kind of see in front of you. So what's correct is that the amount of juice that's left in the bottle specifically depends on the number of gulps you've taken. So if you take more gulps, there's less juice left. So the amount of juice depends, so that tells me that the amount of juice is dependent, and that was y. So y is the dependent variable, it is the amount of juice. All right, and x was the number of gulps. And so that's independent because you control how many gulps you take, but that changes based on how many gulps you take, how much juice remains. So this tells us the domain is 0, 1, 2, 3, and 4. So picture this kind of like a table. 0, 1, 2, 3, and 4. So when they want to know what the range is, you take each x value and plug it back into your equation. So you don't have to show work for this, but just to kind of show you what's going on in my head. I plug in 0 into the equation. So look up here at the top right of the screen. I plug in the 0, so I get negative 3 times 0 plus 12, that's 12. So when I plug in 0, my output's 12. So now let's plug in 1. So where x is where you plug in the 1. So it was negative 3x, so the 1 goes instead of x. So that's your input, and your output, negative 3 times 1 plus 12 is 9. So that means is after 1 gulp, there are 9 ounces left. Okay. And then after 2 gulps, same thing, plug in 2. Feel free to use a calculator if you need to. You get 6. So after 2 gulps, there's 6 ounces left. If you plug in 3, you're going to get 3. And if you plug in 4, you get 0. And that's because after 4 gulps, you have 0 ounces left. So the range is going to be, let's see here, if I go in order, 0, 3, 6, 9, and 12. And I'm just going to list it off like that for each point they gave me. Okay, let's talk about another one. So this one says the function, so they're just giving me the equation. It's not like I know this, it's just part of the problem. So it's not something I have to know, I just have to be able to see it's in the problem. So this function, a equals negative 4b plus 14. Okay, let's read the words. It's always hard to figure it out. Represents the number A of avocados you have. Okay, so A is the number of avocados you have after making B batches of guacamole. So it's like you have a bowl of avocados, and every time you make a batch of guacamole, you use some up. And so how I would say this is I think that the number of avocados you have left depends on the number of batches of guac that you make. Because if you make more batches, then you use more avocados. So the number of avocados you have left depends. That tells me it's dependent. So avocados is dependent. So A, number of avocados left, is dependent on how many batches of guac you make. So B is the number of batches of guacamole. So you make more guacamole, you use up more avocados. If you make less guacamole, then you use up less avocados, which means you have more left on your counter. So the domain is 0, 1, 2, and 3. So then you can think of this like an XY table, but I guess our variables are really B and A. But whatever, it's okay. So we have 0, 1, 2, and 3. So how we find the range is we just go back to that equation they gave us and we plug it in. So after I make 0 batches, I plug 0 in for B, and so I'm left with 14. So at 0 batches, I have 14 avocados. Now try it again, but plug in 1 for B. So if I plug in 1, feel free to use a calculator, I get 10. So after one batch of guacamole, I'm down to 10 avocados left. Once again, plug in 2. So just plug in 2 for X, and I'm going to find out that now I'm down to 6 avocados left. And then after 3 batches, I'm down to 2 avocados left. So your range is 2, 6, 10, and 14. And that's what we would list off for that. Okay, so then we have one more here just to practice it again. So the function t equals 19m plus 65, okay, represents the temperature. So T is the temperature in degrees Fahrenheit of the oven after it started preheating. And M is the number of minutes it has been preheating. So like when you go to make cookies, if you set it on like, I don't know, 350, that's a pretty common temperature, then it does not just get to 350 in a second. It starts at room temperature and then it goes up from there. And so it begins preheating and it warms up slowly until it gets to the whatever temperature you asked for it to be at, and then it'll stop preheating. So I would say the temperature of the oven depends on how long it has been preheating or how many minutes it has been preheating. And remember, you can pause if you need to write something down. I forgot the word bend, sorry. So like if you start the preheating oven right when you get home and you come back in 1 minute later, then maybe it's up to like, I don't know, 100 degrees. But then if you come back 5 minutes later, you've left it a little bit longer, maybe by then it's up to like 250 degrees. So it takes time to preheat the oven. So that means the dependent variable is the temperature, which is T, of the oven, because it depends on how long it has been preheating. So the independent is the M, which is the minutes it was preheating. So if you only give it 2 minutes to preheat, that's not enough time. If you give it 10 minutes, it will get warmer. Okay, a recipe calls for an oven temperature of 350 degrees Fahrenheit. So this is tricky because this one doesn't give us as much information. So describe the domain and range of the function. Well, 350 degrees Fahrenheit is T. So let's go into our equation. We have this equation. Let's put 350 in for T because we can then figure out how many minutes it will take to get to 350. So all I did was plug 350 in for T. Okay, so to solve, you guys, we're going to first subtract 65. And feel free to use a calculator here. I'm sitting here recording this with a calculator. So 350 minus 65 is 285 equals 19m. Now divide by 19 on both sides, and I get 15 equals m. So what that means is it will go from 0 minutes to 15 minutes is how long the domain is, okay? So from 0 to 15, because at 15 minutes, it is reached full temperature. That's the domain. All right, you may have to pause this because I'm just short on recording time. But so basically, to find the range, I know the max temperature is 350. I came over here and I plugged 0 in for M, and that's how I found the start temperature was 65. But feel free to pause it and look at it. And then here is the range. It goes from 65 to 350 degrees.